Welcome to Brain Vision.
Chapter 3, Problem 22 says which of the transition elements in the first transition series have anomalous electron configurations? If we were thinking of the electron configuration for chromium, we would end up with the following. This is the shorthand or outer electron configuration. We take argon, which is the closest complete noble gas, and then we do the remaining configuration. Remembering that the D block always begins with 3. However, this is actually not the electron configuration that we see for chromium. What we actually see is something more like this. Let's make this D a bit better. And let's discuss why. If we were to draw the orbital diagram for the following, just looking at 4s and 3d, we'd have one orbital for our 4s, and the D block would have 5 orbitals. So we have 1, 2, 3, 4, and 5. And all of these are 3D. You put the electrons into the orbitals from the lowest energy to the highest energy. However, 4s has the ability to penetrate and be a little bit lower energy than the 3D orbital. So when we're placing the electrons in, usually we would add another electron here for 4s, but because the 4s and 3D orbitals are so close in energy, what actually happens is the electron that would double in the 4s moves into the 3D orbital to have a half-completed orbital, half-completed sublevels, which actually happens to be lower energy than having only 4 electrons in the orbital. So the fact that there's 1 electron in each orbital is more stable than having 2 here and only 4 here, because these two orbitals are close in energy. We can find this same trend with something like copper. Instead of having 4s2, 3d9, we end up with 4s1, 3d10. And its orbital diagram is as follows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is the 3D diagram. And again, this happens because there's a greater stability with a half or completely filled or sublevels in the orbital as opposed to having 4 or 9 for the electron configuration.